you. I haven't done it I haven't pulled out the answer for us so that we can think through it together. So the lead bullet of mass 5 grams is shot vertically upwards into the wooden block, and they give you the mass of the block as well. So when you see that, you know already it's a collision. So it's going to be something to do with momentum and something to do with energy. There's a collision and movement. It's always going to be momentum and energy, normally in the same question, but it doesn't have to be. But let's see. So in the first question, they say the bullet hits the block with a velocity of 200 meters per second, which they tell us there, and the bullet embeds itself. State the principle of conservation of mechanical energy. Okay, so they do want us to use mechanical energy, otherwise they wouldn't have asked it. So the principle, you have to state it in words, is that the total mechanical energy of the system will remain constant. So please remember that's not the EP plus EK is EMEC. That's the EMEC definition. So, principle of conservation of mechanical energy is that the mechanical energy will remain constant. So that means that EK plus EP must be equal to EK plus EP. Okay, so I'm just writing it because we're probably going to use it. So that's not what you're going to write for the definition. You're going to write it in words, but we're probably going to use that. Then they say calculate the speed of the block and the bullet immediately after the bullet has been embedded into the block. So that is actually momentum. So it's kind of weird. It's probably, yeah, I'm sure this question is from a supplementary because they sometimes do it differently, weirdly. But in a normal paper, the definition would normally lead you to the next question. So they should have rather asked you for the conservation of momentum, but the some of the older supplementaries doesn't do that. But then in 5.2, because it's a collision, it wants the block and the bullet after. So then you're going to say EP. Oh, not EP, momentum. Momentum initial is equal to momentum final. And then you need to think what was moving initially. So it was the bullet that was moving. So the bullet is 200. You can do the whole M1 that whole thing, but you don't have to if there's only one thing moving. But if your teachers want the equation here in the middle, then you have to say VI of, I think you guys use VI of the bullet times by the mass plus naught, because the block was stationary, is going to be VF of the bullet, VF times by the mass of the bullet plus the mass of the block, because they are moving together. So if you know that your teachers want that step, then rather just put it in. The 200 then times by the mass. Please remember that we can't use 5 grams, so it's going to be 5 times 10 to the minus 3, or you can just go 0.005, and then this one is going to be equal to VF, is what they're asking us for. The masses is the 5 plus the 195, so that's going to give us 200 times by 10 to the minus 3. So I also do that to make life shorter, to make the, not life shorter, to make the time that I use shorter. Because if you've got a 10 to the minus 3 and a 10 to the minus 3 there without any pluses and minuses in it, then you can just cancel them out. So we have a 200 times by 5 equals, this step you definitely do not have to put in. 200, is it so seriously going to cancel out? Looks as if it's cancelling out. I don't even have to use my calculator. Please check the maths for me. So I get that VF is 5 meters per second. And that will be, because it's a positive answer, that will be positive. That will be upwards. Yeah, that's what I get. I hope we've done everything right. Right, just check the maths for me, but that is definitely the method. And now they say, how high will the block rise after the block's original position? So here you can now go and use the EK. You can use equation of motion, but they asked us for this, so let's just use it. So we can now say, all right, for we're going to use 5.1 in 5.3, because we're going to say EK plus EP on the floor at position 1. So I'm just going to call that at the floor, or it's a table. Table is equal to EP plus EK at its max position. Now we fill in our values. So in the beginning, they say how high the block will rise above the original position. So we've just worked out the speed that it's leaving the table at. It doesn't have any EP because it hasn't moved yet. So this is going to be our half. I'm putting in that step as well. Half mv squared plus naught is equal, and at its maximum position we know that ek is naught because that's where it's going to stop, and that is mgh. Again, to make your life easier and less time spent on the calculator, you can cancel the m's there. So we get, now we can fill in what we have. We have the initial velocity there was 5 squared is equal to g, oh, not g, 9.8. I know what g is. So 9.8. The height is what we want, h. And now please don't put a negative there. Remember, in MGH, 9.8 does not get a negative. That's a common mistake that people make. So it's a half times 5 times, not 5, times 5 squared gives me 12.5. And I'm going to divide that by 9.8, which gives me 1. So I get the height is going to be equal to 1.2755, so 276, or you can even round it off. Normally they say 2 decimal places, so that's 1.28 meters. Okay, I hope that makes sense. Please send me more if you have more.